Hello everyone, this is your second Karamba tutorial where I want to compare with you and show you how the different geometries that you can create just from a flat sheet are going to behave structurally and which one is in the end more stiff. So I will start with a flat sheet, very simple. I have set up my Karamba definition. I'm using poplar wood as we saw in the previous example. I have put on one side a hinge support and on the other side a sliding support, which means that these 2 points, let's say, can move horizontally only. And I'm applying load that I can change and increase the magnitude, and I can also change direction. The thickness that I start with is 1 centimeter. So here I get a displacement of 40 centimeters. So is this good or is this bad? The deformation is more or less as expected. And now we're going to compare it with an element that would be created if we just bend a flat sheet. We have exactly the same load and exactly the same support conditions, and what happens is that we get an instability. I can show you why. If we push down, these points can slide, which means that this system is not stable. If we change the support to a hinge on both sides, then these 4 points cannot move horizontally. In that case, we have a very, very stiff element that barely deforms. But this means that these horizontal forces need to be taken by what is next to them. It needs to be supported and kept in place. If we move to the next example, here we have put 2 pieces together. I'm going to disable this for 1 second. So here we have taken 2 pieces of flat sheet and we have put them together to create a curved fold. So a geometry like this that has both structural height but also a direction of fold is also very stiff. Here, the problem that is created can just be easily fixed by changing the rotational conditions at that point, which is easier to do. As you can see, my element doesn't deform. Even if I increase the visualization a lot. So this is a more stable component, a stiffer component, which is something to look for. So I'm going to continue with the next one. Where I have combined one stripe that is curved with one stripe that is flat. So this component is again stable. I can put back my sliding support because I don't need it. And again, I'm going to end up with a quite stiff component. The problem is in this one, as you see, and if we would apply loads, or if we would apply a load from this direction, is that these two can start to open up. So moving to the final geometry that I wanted to show you. Sorry. Okay, back to the third example, which now works better. I have my geometry input. I'm going to set this back to enable. And just quickly show you how stiff this component is. I can apply load, I can change the direction. I don't need the second support. This is a self-stable system. And I can have a very small displacement. So it's good for you to think in this direction and try to combine different layers together in order to acquire more inertia and end up with higher stiffness. So what I want you to do is to try to test the geometries that you create with paper, see how they behave, and take some decisions based on that. And I want you to do that by modeling them in Grasshopper and using the properties of paper so that you can easily compare with the physical model that you create by hand. Okay, if you have more questions, we're gonna speak about them later.